Are you a middle school, high school, or even a college student? If yes, then this video is for you. Today, we're diving into one of the most essential skills in science and math. Mastering units and conversions. Let's make this super easy and fun. Now, imagine a world where we had no standard units for time, mass, or even distance. Sounds like total chaos, right? How would you even measure your height? Your age? How long is your favorite YouTube video? It would be like living in a world with no rules. Okay, let's make it even simpler. If I came up to you and said, "You have 50. You'd probably say, 50 what? Is it 50 kilometers? 50 kilograms? Or maybe 50 minutes? See? Numbers without units are like a puzzle with missing pieces. You might have the right number, but without a unit, it doesn't make sense. So today, we're diving into units, so we can properly distinguish between different measurements and give each number its real value. Units aren't just random labels, they're actually divided into two big categories. Think of basic units as the building blocks of measurement. They're the foundation we use to create derived units, which are combinations of these basics. Now, let's talk about basic units, the core measurements that define our world. Length, measured in meters, m, or feet, feet. Mass, measured in kilograms, kg, or pounds, lb. Time, measured in seconds, s. These three units are everywhere in science, math, and daily life. But what happens when we combine them to make even more useful measurements? Now, we've talked about the basic units, but what about the more complex measurements? That's where derived units come in. Derived units are made by combining basic units, and they help us measure things like area length times width, speed distance divided by time, force mass times acceleration. And there are many more. We'll explore them as we go through the video. But wait, why do we even express length in meters or mass in kilograms? That's an amazing question, and it leads us to the next big topic, systems of units. Did you know there's more than one system of units? Engineers and scientists around the world follow the International System of Units, SI. In this system, we measure length by meters, m. Mass by kilograms, kg. Time by seconds, s. This system is used by engineers worldwide, making calculations easier and standardized. But SI isn't the only system out there. In the United States, a different system is widely used, called the FPS system. In the FPS system, length by feet, mass by pounds, time by seconds. That's why you might hear distances in miles instead of kilometers, or weight in pounds instead of kilograms. So, whether you're in Europe using kilograms or in the US using pounds, both systems serve the same purpose, to measure our world accurately. Alright, let's dive into length measurement and how it's expressed in different systems. But today, we're doing something special. Along with the international and FPS systems, we'll also take a look at the ancient Egyptian system, and my friend from Egypt will share some of those units with us. In the international system, we measure length in meters. But did you know the meter has a whole family of multiples and submultiples? Kilometer equals 1,000 meters, for long distances like roads. Centimeter equals 1 over 100 of a meter, for small measurements, like rulers. Millimeter equals 1 over 1,000 of a meter, used in engineering and design. Micrometer equals 1 over 1 million meters, for microscopic objects. Nanometer equals 1 over 1 billion of a meter, for atoms and molecules. So whether you're measuring a highway or a tiny microchip, there's a perfect unit for the job. Now, in the FPS system, things work a little differently. Inch. About the size of a thumb. Foot. Used for height and room dimensions. Yard. A bit shorter than a meter. Mile. Used for long road distances. These units are widely used in the US, and now you can see how they compare to meters. But now, let's take a journey way back in time. How did the ancient Egyptians measure length? Let's find out. The ancient Egyptians used fascinating units like that on the screen. It's amazing how measurement has evolved over thousands of years. Now that we've covered length, let's talk about something we all deal with, mass. In the international system, SI, we measure mass using kilogram, the main unit. Used for people, groceries, and more. Gram equals over 1,000 of a kilogram, used for small objects, sugar or coins. Ton equals 1,000 kilograms, used for trucks, buildings, and heavy objects. But in the FPS system, mass is measured in pounds, lb. And of course, we always compare it back to the kilogram, the base unit. So, whether you're lifting weights in grams or measuring flour in pounds, both systems help us measure mass accurately. Now, let's talk about something everyone understands, time. Time is one of the few basic units that remains the same in all systems. Whether you use SI or FPS, you'll always see seconds, the base unit, used in physics, calculations, and precise timing. Minutes equals to 60 seconds, used in daily life, schedules, and sports. Hours equals to 60 minutes or 3,600 seconds, for work shifts, flights, and more. So, no matter where you are, a second is always a second. Now that we've covered all the basic units, it's time to dive into derived units, starting with area. In the SI system, the area is measured in square meters. But in the FPS system, we use square feet. Here's a cool trick. Since area is just length times width, we can convert any unit of length into area by simply squaring it. This means if we know how to convert between meters and feet, we can also convert square meters and square feet easily. Now, when we talk about large areas of land, we use special units that make measurement easier. Two of the most commonly used land area units are hectare, and it equals to 10,000 square meters, about the size of 1.5 soccer fields. Acre, and it equals to 4,050 square meters, used for farmland, real estate, and more. But did you know that different countries have their own traditional land measurement units? In Egypt, farmers use unique local units to express land area, and here they are on the screen. Now, let's move from flat land to 3D space. Welcome to the volume. In the international system, volume is measured in cubic meters. But we also commonly express volume in liters. And 1 cubic meter equals 1,000 liters, used for drinks, fuel, and household liquids. Gallons. And 1 gallon is almost equal to 3.8 liters, common in the US for fuel and milk. So, whether you're filling up a swimming pool, measuring fuel in your car, or buying a bottle of soda, you're using volume units every day. Next up is speed. The speed is one of the most important derived units. Speed is simply distance divided by time, and its standard unit is meters per second, the SI base unit. Used in science and physics. Kilometers per hour, common in daily life, used for speed limits. Miles per hour, mph, used in the US, for cars, running speeds, and sports. That means whether you're driving, running, or even watching a falcon dive at 242 miles per hour. Speed is everywhere. Now, let's talk about force. The reason behind why things move, stop, or change direction. Force is simply mass times acceleration. And when we multiply mass by gravity, we get the force known as Newton. Newton is the unit of force. Named after Sir Isaac Newton. So, whether it's a ball falling due to gravity, a car speeding up, or a rocket escaping Earth's pull, force is at play. Next, let's talk about density, a unit that tells us how compact a material is. Density is simply mass over volume, and it's measured in kilograms per cubic meter, and it is the SI unit. Notes that water has a density of 1000 kilograms per cubic meter, which is why some objects float while others sink. Ever wondered why your ears pop in an airplane? Or why deep-sea divers feel intense pressure? That's because of pressure. Pressure is simply force over area. And in liquids, we calculate it as density multiply gravity multiply head. The deeper you go, the more pressure you feel. Also, pressure is measured in different units. Pascal is the SI unit. 1 Pascal equals 1 N per m superscript 2. Bar, often used in weather reports and engineering. PSI, pounds per square inch, used for tire pressure and hydraulics. Atmospheric pressure, ATM, the air pressure we feel at sea level. No matter where you are, underwater, in the sky, or on land, pressure is always affecting you. Let's talk about flow rate. Also known as discharge, the amount of water moving in a certain time. We measure discharge in cubic meters per second, used in hydrology, engineering, and plumbing. Gallons per minute, GPM, common in household water flow and fire hoses. So, whether it's a small tap or a raging river, understanding flow rate helps us manage water efficiently. Alright. We're down to our final topic for today. The power. But what exactly is power? Power is simply force multiply speed. But also, in hydraulics, power is measured as pressure multiply discharge, used in machines, pumps, and industrial systems. And how do we measure power? First by watts, and it is the SI unit for power. Used in electricity, physics, and engineering. Kilowatts, 1000 watts. Common for motors and appliances. Horsepower, used for cars, engines, and heavy machinery. So, whether it's a car engine, a power plant, or a hydraulic pump, power keeps things moving. Let's apply what we've learned with a real-world example. The peregrine falcon, and it is the fastest animal on Earth, reaches a top speed of 242 miles per hour. But how fast is that in meters per second, the SI unit? To convert, we use this conversion factor. This gives us approximately 108 meters per second, an insane speed for a bird. So next time you see a falcon dive, you'll know it's moving at over 100 meters per second, faster than most supercars. Now, let's take another real-life example, converting land area. You have a 100,000 square foot plot of land, but you need to express it in hectares, the unit commonly used in the SI system. How do we do that? Alright. Let's break down our final example step by step. First, we need to know how many square meters are in 1 square foot. We already know that, right? So, if we have 100,000 square feet, we use the conversion factor also. So, now, let's convert square meters to hectares. And there you have it. Your 100,000 square feet land is about 0.93 hectares, almost the size of 1.5 soccer fields. Now, let's see if you can apply what you've learned. Here are 2 examples for you to solve. Drop your answers in the comments below, and we'll see who gets it right. And that's a wrap for today's lesson. I hope you found this video useful and easy to follow. If you did, like the video if you learned something new. Share it with friends who need help with unit conversions. Subscribe so you don't miss upcoming lessons. We've got tons of exciting, useful content coming your way, so stay tuned. See you in the next video.